Welcome to a lesson on ratios and proportions. This lesson is being done on a series that I'm putting together on similar figures in geometry. So you could consider this an introductory geometry or review lesson. I'm Mr. Pi the Math Guy. Let's take a look at some stuff here. Here we're talking about ratios in this lesson on ratios and proportions. Here's a definition of a ratio. A ratio is a comparison of two numbers or quantities with a division. So since we can use division to compare two numbers, it's going to be a quotient. We can express it as a fraction. Here's how we can talk about ratios. The ratio of A to B, or A colon B, is written as the quotient A over B when B is not equal to 0. First of all, B is not allowed to be equal to 0 because we're not allowed to divide by 0. It's undefined. This comparison in orange is the most useful to us mathematically. The reason being, we can set up proportions from it. We're going to learn about that a little later in this lesson. Here are two other ways to express a ratio. This right here, A to B with the word to, is usually for the spoken word, and this would be another way to express it in the written hand, as opposed to a fraction if you had to use a typewriter or old word processing. So let's take a look at how to set up a ratio given a real-world problem-solving situation. Example 1. A scale model car is 4 inches long. The actual car is 15 feet long. What is the ratio of the length of the model to the length of the car? We understand that we're going to need to set up a ratio because it tells us to. It asks us right here, what is the ratio of the length of the car to the length of, or the length of the model to the length of the car. So we're comparing the model to the car. Of course, we're comparing the length of the model to the length of the car, but to simplify it, we're comparing the length of the model to the length of the actual car. So we just fill the numbers in. The scale would be 4 inches to 15 feet. It doesn't ask us to reduce it or anything, so here we have found the ratio. And really in this example, what we've done is defined the idea of scale. The scale of any scale model where you're making something bigger or smaller is defined as the length on the model over the length of the actual. So there's how to use a ratio. Here we are defining a proportion. A proportion is a statement that two ratios are equal. We could write it with a colon and say it as A to B is equal to C to D. It can be rewritten as A over B is equal to C over D. So this is a proportion. Two equal fractions or two equal ratios make a proportion. An extended proportion is a statement that three or more ratios are equal. Here we have an extended proportions numerically. We know that 5/15 is equal to 2/6 is equal to 1/3 because 5/15 and 2/6 both reduce to 1/3. So here we have an example of an extended proportion. So let's take a look at some more ideas and terminology related to proportions. Now that we've defined proportions, we can take a look at the properties of proportions. Here, given the proportion A over B is equal to C over D, we can conclude or know that it is equivalent to one of these four statements. In the first statement, what we do is we take what's called the cross products. We multiply the diagonals. A times D is equal to B times C. So that's one property, the cross products property. We're going to learn about that in more detail in a little bit. Next, what we have to do here is compare what do I do to what I'm given in the blue to what's here in the orange. And you can see it's A over B. And here the property states that if I inverse the left side, if I make A over B into B over A, then I have to invert the right side to maintain the equality. That I have to change C over D into D over C. Another property that we have here is illustrated by this proportion. Starting with what we have in the blue, I start with A over B equal to C over D. If we look what we have here, the first ratio is A over C. And I kind of think of it as left to right, A over C. So it's A over C. So then the other half is going to be B over D, which it is, B over D. So this property says we can make the proportion this way from the numerators and the proportion from the denominators. Here's another property. We have the A's in the A and B in the numerators, and we have the C and D in the numerators on the other side. But what we notice is that we add the denominator to each numerator on its own side. So here we have A over B can also be thought of as A plus B over B equal to C plus D over D. So adding the denominators in. Let's take a look at how to apply these properties of proportions next. Here in example 2, we're asked to complete a statement. The statement is, if x over 4 is equal to 12 over y, then y over 12 is equal to what over what? Well, if we think of it in terms of starting with a ratio, like we did with the properties, and you can see I brought the properties over here, so we have them to refer to. If we start with A over B, or in this case, x over 4, and that's equal to C over D, or 12 over y, what is y over 12 going to be equal to? So what we can see is, from the original proportion, what happens? We inverse the second proportion. We write 12 over y as y over 12. Therefore, we're going to need to invert this side, x over 4, and we're going to invert it, and it's going to become 4 over x. So a complete answer here would be y over 12 is equal to 4 over x. So there's applying and understanding the properties of proportions. Being that this is a geometry video, what I'm about to say shouldn't really be new, but I don't like to assume anything. I want to make sure that you have all your prior knowledge, or at least I refresh that prior knowledge before we get started. Here we have the cross products property. The product of the extremes is equal to the product of the means. Well, when we're given this proportion, A to B is equal to C to D, the inside terms here, B and C, are called the means. The outside terms, A and D, are called the extremes. In terms of a proportion, when we have it as A over B is equal to C over D, we can rewrite that, as we saw in the other properties, as A times D, or we multiply this way, and then B times C, because we multiply that way. Hence, we cross multiply. A lot of students do like to call this cross multiplication. I like to say using cross products. In example 3, we are asked to solve the proportion. This is a simple application of the cross products property. Here we have 2/5 is equal to n 35ths, or 2 over 5 is equal to n over 35. Applying the cross products property, we're going to do 35 times 2, and that gives us 70. We have 5 times n on the right-hand side of that equation now. Now, if we are doing this as a geometry proof, we could write that this is our given. Considering this is a geometry lesson, we could do this. To cite this line, we would say that we use the cross products property. Definitely can abbreviate here. From here, we would divide each side by 5. This side being divided by 5 would give us n. 70 divided by 5. 5 goes into 7 one time, 2 left over. 5 goes into 20 4 times, so we have 14 is equal to n, and we got that by the division property of equality. And then finally, I like to turn my equations around so the variable's on the left-hand side. So we have n is equal to 14. That would be the final answer if you were looking for 1. It's a 14 right there. That would be the final answer, and that would be cited by the symmetric property of equality. So they're kind of using some algebra and connecting it to the geometry that you should have been studying if you're watching this lesson. In example 4, we're again asked to solve the proportion. That's like we just did in example 3. But this proportion looks more like of a problem you might run into on a standardized test. It's very algebraic. So we're not even going to worry about citing the reasons. We're just going to solve the proportion. Using the cross products, we're going to have to go 2 times x plus 1. Notice when I said that, I went like I put a set of parentheses in, but I didn't. But when I write the cross product down, I'm going to put parentheses in. So that'd be 2 times the quantity x plus 1. That's the one cross product. The other cross product is 3 times x. So now we have a more complicated equation to solve. To solve this equation, we first have to use the distributive property to distribute the 2. 2 times x is 2x. 2 times 2 is 2. And that is equal to 3x. In this case, I have variables on both sides of the equal sign, so I'm going to get rid of one of those by subtracting it from both sides. So I'm going to subtract 2x from both sides. Doing that, the 2x's on the left disappear, giving us 2 on the left. 3x take away 2x is x. So we have our equation solved. Turning it around using the symmetric property, we have x is equal to 2. So our solution here is x is equal to 2. Here in example 5, we're given some information about 2 cities. They are 3.5 inches apart on a map with a scale of 1 inch to 50 miles. We are asked to find the actual distance. So we're working with scale, so we're comparing the scale distance to the actual distance. So in this case, what we'll do is we'll fill in this information first. We know that 1 inch is equal to 50 miles, so in this case we'll go 1 over 50. 1 inch is equal to 50 miles, is equal to 3.5 inches. That's a scale distance. That's the distance on a map, and that's 3.5. Instead of using a fraction there, you could easily replace that with 3.5 inches. And we're being asked to find the actual distance. So we simply solve this proportion. X times 1 is equal to x. And 50 times 3.5. Well, 50 times 3 is 150. And half of 50 is 25. So if we add those together, that gives us 175. So the actual distance here is 175 miles. Example 6. A tire factory in Detroit can produce 15-inch tires at a rate of 750 per hour. How many hours would it take the factory to make enough tires for 25,000 new cars? Well, you can see I've given you the correct answer here. The correct answer is C. That correct answer is the best choice of C and D because it's the right answer. Out of A and C, you can see they're very similar. They both have 133 in them. It's the best choice there because it's expressed in hours and minutes. It's more accurate, more understandable than choice A. So that's one reason, or that's how we can eliminate A. Now, how do we arrive at 133 versus 33? Let's take a look at that. This is a proportion problem, and it really, the word that should key you into it, it's a proportion problem. You're given a rate, and that rate compares 750 tires per hour. So they can make 750 tires per hour. So the ratio, or the rate, can be expressed as tires over hours. Now that helps us set up our proportion. The first part of our proportion is going to be 750 over 1. 750 tires in 1 hour. Here's where a mistake gets made. To find how many hours it's going to take to produce the needed tires, students like to put in 25,000 here. And that's not the correct answer. That's not the correct number to put in there. That's how many cars. You have to think about how many tires would come on a new car. 4. So you have to take 25,000 and multiply it by 4 to get 100,000. You're going to need 100,000 tires for these cars. So instead of 25,000 here, you would use 100,000. Over X, because that's how many hours, and that's the question. It asks us how many hours. So when we solve this proportion using cross products, X times 750 gives 750X. 1 times 100,000 gives 100,000. When you divide 100,000 by 750, it gives 133.3. And that's why a lot of students want to jump on answer A. They're using a calculator. 133.3 jumps up on the calculator, and they get A, and they see it, and they think it's correct, but it's not. How do we change 133.3 into choice C, 18 minutes? Well, there's a couple ways to do it, but it really breaks down in the idea that there's 60 minutes in an hour. And if we have 3/10 of an hour, of course this is a rounded number, it's 133.3 repeating on your calculator, but it's obviously been rounded to 0.3. If you think of an hour as 60 minutes, if you take 60 times 0.3, which would be 3/10 of an hour, that gives 18. And another way to get that 18 is just to go 6 times 3 to give 18. Because there's, in 3/10 of an hour, 30% of an hour, there are 18 minutes. Or every 10th of an hour, there are 6 minutes, and you multiply that by 3 to get the 18 minutes. So that's how you end up with the wrong answer and how you end up at the correct answer. Now, the mistake I pointed out earlier, by putting the 25,000 in here, that would either lead to choice B or choice D. 25,000 divided by 750 gives 33. So I hope this helps you on any standardized test you may be taking in your near future.